Have you ever looked up at the night sky? I mean, really looked, past the city lights, past the airplanes blinking in the distance, find a truly dark spot, and the sky becomes a canvas splattered with countless points of light. Many are stars, just like our sun. Some are entire galaxies, each with billions of their own suns. It's humbling. It makes you wonder, what's happening in the vast, silent darkness between those shining dots? Our solar system feels familiar, but it's just one tiny neighborhood in a cosmic city. The journey begins now. Let's start with something you can't see, touch, or feel. In fact, scientists have never directly observed it. It's called dark matter. Dark means no light, matter means mass, and gravity. Dark matter is like the wind. You can't see it, but you can see what it moves. We see dark matter's gravity tugging on stars and bending light. In spiral galaxies, outer stars move so fast they should fly off. Yet they don't. Something unseen holds them in, a halo of dark matter. About 85% of all matter is dark. We are the exception, not the rule. The story of dark matter began as a slow realization. In the 1930s, Fritz Zwicky studied the Coma cluster. Galaxies there moved too fast for visible gravity to bind them. He proposed Dunkel Materie, dark matter. For decades, many assumed he was wrong. In the 1970s, Vera Rubin and Kent Ford measured galaxy rotation precisely. Outer stars moved as fast as inner ones, a flat rotation curve. Visible matter is just the tip of the iceberg. Galaxies sit in massive, invisible halos. The fringe became a pillar. Dark matter transformed cosmology. Now, something so dense that not even light escapes. A black hole. Supermassive ones weigh millions, even billions of suns. They anchor galaxies at their centers. Our Milky Way's is Sagittarius A, about 4 million suns, 26,000 light-years away. Stellar black holes form from dead giants, but building a supermassive one quickly is a puzzle. Maybe direct collapse, or many mergers in young galaxy centers. Their accretion disks can outshine whole galaxies, quasars in the young universe. Monsters and engines, they regulate how galaxies grow. If black holes are black and buried in dust, how do we know they're there? First hints came from radio, a powerful compact source at our center. Proof took decades of patient observing. Teams led by Reinhard Genzel and Andrea Ghez tracked individual stars. They saw stars whip around an invisible mass at incredible speeds. Using Kepler's laws, they weighed the object. The result, 4 million suns in a very small space, Sagittarius A. In 2020, Genzel and Ghez earned the Nobel Prize. In 2019, the Event Horizon Telescope showed a black hole silhouette, the shadow of its event horizon. Imagine listening to the static of the cosmos. Suddenly, a burst only milliseconds long, and then, silence. These are fast radio bursts, intense blasts from far beyond our galaxy. In a blink, an FRB can outshine our sun's daily output. Some rival decades. The first FRB, found in 2007 by Duncan Lorimer and David Narkovich, looked like a glitch. They ruled out interference. The signal was real and extragalactic. Now we've cataloged hundreds. Most burst once, a few repeat. Repeaters told us the source must survive its own fireworks. What can unleash such a brief, brutal burst? One prime suspect, magnetars, hypermagnetic neutron stars. A starquake can snap field lines and dump colossal energy as radio. In 2020, a Milky Way magnetar produced a radio burst, a smoking gun. But some repeat on schedules, hard to explain with random quakes. Perhaps a magnetar in a binary. Signals reach us at a specific orbital phase. Could it be aliens? Fun to ponder, but nature is extreme enough. FRBs are a brand new puzzle and the chase is on. The possibilities are thrilling. We think of planets as families orbiting stars, but some have no sun to call home. Early gravitational chaos can fling a world into the void. A slingshot past a giant can launch it forever. These worlds are faint, cold, almost completely dark. We find them with gravitational microlensing, mass-bending light. A short brightening signals a planet-sized lens. It's a needle in a galaxy haystack. We've confirmed some, and suspect billions, maybe trillions, drift in the dark. From dark matter's invisible glue to lonely rogue planets, to supermassive black holes and fast radio bursts, these aren't curiosities. They're signposts of our ignorance, new rules to learn, new physics to discover. Discoveries came to those who looked, and stayed open to surprise. Our tools can hear black holes collide and see back toward cosmic dawn. Yet our knowledge is still a small island in a vast ocean. Stay curious. Look up. Read. Ask questions. And wonder. The universe is the greatest detective story, and we all have front row seats. Let's keep exploring.